Okay, so I can have a choice of either showing a lot of slides, a little video, or a demo. And I guess I'll show a few slides and some video, and then maybe I'll show a demo later on, like in a break. So I'm Sheldon Brown. I'm a professor at UC San Diego and direct this pretty new research center, the Arthur C. Clarke Center for Human Imagination, and run a National Science Foundation funded lab on parallel computing. I'm getting 100 texts right now. So let me just show this. This is probably the most efficient way to kind of just give a little overview, which is this 4-minute video. It's mostly focused on a pretty new project, but shows a few previous projects.
The continued development of the reach of computing is now bringing new types of emergent phenomena into its grasp. We are entering a new era in which human activity will be transformed by the ongoing developments between data, algorithms, and people. This formula will change the way we learn, create knowledge, and communicate with each other. We are creating a platform in which our computing systems can develop, learn, and evolve to provide emergent behavior out of the interactions between data and users. Our first demonstration of this approach is a project called Assembly, in which an algorithmic basis of evolutionary processes has been created. A synthetic system of encoding characteristics and a set of rules akin to the chemistry and physics of an environment provide a basis for creating increasingly complex emergent behavior. However, these genetic and environmental conditions are abstractions of an underlying scheme which can be applied to various types of data. In the Assembly project, we show this by working through 3 levels of representation that evoke 1. The cellular, 2. The organism, and 3. The socio-cultural. The system runs across a variety of computing platforms. On portable devices, you attempt to cultivating a single assembly at any of the 3 levels of representation. Your entity is part of a larger colony, which you are able to engage and experience through higher fidelity tools such as a computer, game platform, or virtual reality device. These assemblies grow and change as your own interactions with the assembly deepen. At the highest level, your assembly becomes an avatar in a complex cultural environment, showing how this approach can become a vehicle for interaction in an information-dense world. Through this work, we are building a systematic approach for nurturing computational entities to have increasing agency in their context. Creating this relationship will change the way we interact with computers, providing us with experiences of greater insight, supporting how we work, play, live, and learn.
So this is a current project, which is this kind of metabolic and genomic simulation that gets applied to different kinds of representations, as the video said. And in all of this, so what I really do is I'm an artist and do these, and this is the kind of realm that I've been working in for quite some time. These kind of virtual worlds that are very procedurally driven, that look at both the kind of social and the way the social is kind of renegotiated via the algorithmic and computational project. Probably some of you know, Scalable City, long-term project that has all these different outcomes, where we really develop this kind of procedural engine to do asset development. It's been shown lots of places around the world. And it led to really this kind of deepening research in the kind of parallel computing methods of doing these large-scale, complex game and virtual worlds. So out of it, so the work is mostly funded by the National Science Foundation and industry partners, and but its outcomes are mostly in cultural institutions. So there, we write papers on the stuff we do. We build new kind of novel computational infrastructure to do these things, and have some different techniques that have developed out of this. So a lot of the work goes back and forth between cinema and games, and some of that is just because real-time platforms, speaking of real-time, is always kind of catching up to kind of cinematic methods. So we're always in real time working out what cinema developed 20 years previously. But that leads to some very different problems that cinema addresses, and one of which is real-time human behavior and experience. So this has been increasingly the kinds of things we've looked at in these environments, is how do we know what people are thinking when they're doing these things? And so can we annotate the virtual worlds in ways that tease out behavior, compare many thousands of people's engagements in these environments and understand emerging patterns of behavior? And I've got a bunch of videos that show this that I won't talk about. And then there might be some ways to apply that to other domains. So one more last quick video. This project called Verbella that I've been doing with the business school, which is a online virtual world environment. We've done this collaboration with 8 business schools around the world and some other universities that you recognize.
At Verbella, we aim to improve online education. We develop and deliver virtual world learning platforms that allow for blended learning, including the ability to host lectures, engage in group projects, attend student fairs, play serious games, receive coaching, and compete in simulations. Since our last update, we have started to create and support custom online campuses for universities. The University of California, Irvine has had over 200 students utilising Verbella to join lectures, meet with professors during office hours, and collaborate with fellow students to work on real-world problems. Meanwhile, our development team has continued to develop resources to foster learning and collaboration, as well as tools to research data-driven assessment of leadership and team cohesion. Thank you to the GMAT Met Fund for making it possible.
Oh, geez, yeah.
Check out our demo at verbella.com.
So so we are able to kind of look at human behavior as
let's look at the other thing.
So this is kind of an example of writing that
Let's do it,
shows this
please.
global
Oh my
business
God,
competition of these
finally.
people collaborating for the first time, meeting for the first time, and having to run through a simulation engine.
We're below suit.
But with this, we have this data that we can assess what people are doing and even look at very coarse characteristics about like voice inflection to see who are high-performing teams. And then the ultimate aim to get to how we actually do this. So we have a research project with 64,000 Commodore 64s connected. No, we should though. But now we're bringing EEG analysis into this as another kind of real-time signal. So this is an NSF funded project that we are doing now that particularly looks at kind of spatial knowledge, and there's particular parts of the brain that that are well attenuated to kind of revealing certain kinds of aspects of spatial navigation. And all of this is within this rubric of the Arthur C. Clarke Center for Human Imagination, which we want to do this, and we have all these people that do it, and all these people that fund it, and these great science fiction authors who are part of it, and hope you all can come and participate in some of the things we're doing. So, great. Thanks.
Questions for Sheldon?
What kind of virtual environment was that you were designing for education, the Verbella?
The Verbella? Yeah, so it's it's designed for education and collaboration and assessment. So it kind of combines those 3 kinds of modalities. And it's a platform that we've developed ourselves, and we wanted it to be kind of like you get in it, you spend like 3 minutes learning how to use it, and then you can use it. So really kind of low barrier of entry, and to really look at then how do we design the way in which the virtual world can respond to the dynamic behavior of groups and individuals.
Given that you're looking at the way people interact and you're looking at how they behave, and you're trying sort of recording their voice and their inflection on, what did you do about the avatar design? That's a very critical
So
way
for
of how
this,
people
so for this, we have a very limited palette of avatar design. So there's an avatar design engine. We're trying to limit, so it was a kind of a deliberate choice we made to limit the kind of time that people are spending doing the avatar design. They have quite a bit of customization, but they're not going to build like really outlandish, exciting avatars. There's no dragon button in here. And in part, we were comparing this to what people's experience with using, say, like Second Life in a kind of online learning and collaboration environments. And people spend a lot of time designing avatars in those environments. Some people, and it attracts a certain kind of audience. We're looking to engage another kind of audience. Okay, thanks.
All right, thank you.